Good morning. Welcome to the session of Instrumentation Engineering. So today the discussion topic is feed forward and the ratio control part 2. So already we have discussed about few points about the feed forward control, and the feedback control we have already discussed in that particular topic. So now it's time to go forward to acknowledge the merits and demerits of the feed forward control, and also another type of control strategy, which is the ratio control. The prerequisite to understand this particular topic is sensor and transducer, industrial instrumentation, and control theory. So from the previous lecture, if you try to make the merits and demerits of the feed forward control and the feedback control itself, so it already mentioned over here in that particular slide with the few points. So if you talk about the feed forward control merits itself, so it takes the corrective action before the process feels the disturbance. So as I already mentioned, that the feed forward control strategy is anticipatory in nature. So we are able to feel before the disturbance happen to the process. And this particular demerits, if we talk about, it requires measurement of all disturbance affecting the system. So that means that there will be no chance that a single disturbance will happen in an actual process or the practical processes. There are multiple number of disturbance can be incorporated in a process. So that means the demerits, we can say, if we are not acknowledging any one of the points or any one of the section through which the disturbance can be occurred into the process, so that is a major drawback or the demerits, we can say. We need to acknowledge all the points through which the disturbance can be incorporated into the process. So that is the point itself we can be considered to be as a demerits of the feed forward control. If we talk about the next merits itself, good for sluggish system and or system with large dead time. So already, as I mentioned, for the demerits of the feedback control loop is if the dead time or the delay dominated process we are talking about to control. So in such cases, the delay dominated process itself not controllable using the feedback control. So in such cases, we can go for the feed forward control for the operation or the control strategies. Sensitive to the variation in process parameters. So because for the case of the feed forward control, we have used the process transfer function itself. So the sensitivity or the variation of the process parameters, that means the open loop gain, the time constant, the date time, if that particular variables or the particular parameters are being changed, so in such cases it can be considered to be as a demerits of the feed forward control, because it is need to be expected that whatever the actual process is there, the transfer function or the model of that particular process needs to be perfect enough. Does not affect the stability of the process, because we are not concerned about the feedback or the concern about the output of a process. So there is no concern about the stability. We are only concerning about the rejection of disturbances. Requires a near perfect model of the process. As I already mentioned, that perfect modeling is required whenever you are only using the feed forward control in a single control strategy without using the feedback itself with accompanied through the feed forward one. So nearly perfect model required to use the feed forward control individually to control any type of processes where the disturbance has been incorporated. If we talk about the feedback controller, so does not require any disturbance measurement, because whenever we are taking the measurement of the output using the sensor or the transmitter, so it is already defined that all the particular disturbances are incorporated in the process, and the process parameter actually disturbed or deviated by all the disturbances. So there will be no requirement to make the change of the disturbance or to find out the change of the disturbance in different position or the different points. So that's why there will be no requirement to measure the disturbance individually. Acts to takes the corrective action after the process feels the disturbance. So demerits already we have talked about, because it is known as compensatory in nature. So it is very evidently proved that whatever the actions has been given, whatever the disturbance has been given into the particular process, so that will be feel after that particular disturbance incorporated into the process. So it can be called as a demerits for the case of the feedback control. Insensitive to mild errors in modeling. So it is a merit, or it can be called as a merit, because there will be no requirement for the case of the feedback control to go through the modeling or the transfer function of that process, because whatever the sensor or the transmitter is taking the output parameters, so obviously there will be no requirement such cases of the modeling. So it will be a very good benefit or the merits we can say for the case of the feedback. Bad for the sluggish system and or system with the large dead time, because the dead time is already make the control action with a specified delay of time. So that is another point we can say, that the sluggish system or the system which is accompanied with the dead time, that cannot be considered or that cannot be controlled by the feedback control strategy or the feedback controllers itself, that can be considered to be as a demerits of that particular strategy. Insensitive to mild change in process parameter, already I have mentioned that there will be no requirement for the case of the process transfer function or the process parameters, because we are taking the output value using the sensor and transducer in the feedback controllers. So that's why there, that is personally can be called taking as a merits for the case of the feedback controllers. May affect the stability of the process, because we are talking about the output and we are talking about the output parameters or the output value of that particular parameter which we need to control, that needs to be come up with the stability factors, gain margin, phase margin, and all the cases. So that is the demerits we can say for the case of the feedback control. So now we will proceed towards two of the application area of the feed forward control, in which first example which we have taken as a heat exchanger. So in the heat exchanger itself, you are able to see that we have given some inputs, which is nothing but the liquid, and the liquid temperature need to be increased by the steam input. So in such cases, what we need to do is we need to measure the temperature of the output of that particular stream or the liquid, which temperature need to be measured. But here we are able to observe that there will be no sensor accompanied with the output side of the temperature which need to be maintained. Otherwise, we are using two of the sensors at the input side of the liquid stream, which we have observed as a disturbance area. So flow transmitter and the temperature transmitter, which are already denoted as FT and TT, they are accompanied at the input side of the liquid stream. We are predicting that these 2 points or these two factors can be make the disturbance into our process or the heat exchanging system. So that's why here you can see the FT, this flow transmitter and temperature transmitter, has been given, and the feed forward control make the desired changes as per the steam flow rate whenever the disturbance has been incorporated or the disturbance has been accompanied using this particular flow transmitter and the temperature transmitter. Before it happens to the process, the feed forward control will make the changes or the take the corrective action, and using this final control element, the steam flow rate will be changing according to the change of the disturbance which will be given in the heat exchanger. So that is a very typical process we are talking about, in which we are only using the feed forward control, but we are not at all using the feedback control here in that particular system. Now, another very interesting part of the discussion is the boiler drum level control. So here you are able to see the entire process is nothing but to maintain the level of that particular drum. So here a level transmitter is required for the case of the feedback control. But because we are only concerned about the feed forward control, so we are only concerned about the disturbances. So here you can see the feed water or the feed which is given to this particular boiler drum using the economizer, superheater, evaporator, these particular sections. So here this feed water, the flow of this feed water will be considered as a disturbance. So that's why FT, which is the flow transmitter, we have incorporated, and using the flow transmitter, we are using the feed forward control. And another disturbance which we have identified, which is the flow rate which is coming out from the output side, which is nothing but the superheated steam. So here also another flow transmitter we have given. So here we have identified two of the disturbance point through which the disturbance can be incorporated. But the case is there are multiple number of chances is the process. So that's why two of the disturbance will be given to the feed forward control, and accordingly the corrective actions will be taken, and the action will be incorporated through the final control element or the control valve, which is nothing but another example of the feed forward control individually used for the maintaining of boiler drum level. So that is are the two of the practical examples or the very important examples, we can say very popular example, through which we are able to understood the feed forward control strategy. Now coming forward to the another type of control, which is nothing but the ratio control. So most of the cases, if we talk about the boiler, so there the ratio needs to be maintained in a very specific manner, because the ratio of the fuel and air in a boiler is always a challenging task for the engineers. So that's why this type of control strategy is very beneficiary at that particular point of the discussion, and that's why the ratio control is our point of discussion today. The ratio control is nothing but a special type of feed-forward control where two disturbances are measured and held in a constant ratio to each other. So what we try to do for the ratio control is we try to maintain the ratio of two of the loads or the disturbances. That means two of the stream is flowing through in a pipeline, and in that cases one of the stream will be talking about as a wild stream and another stream will be talking about as a controllable stream. So we'll try to control one of them and try to maintain the ratio as per our desired level, and it is mostly used to control the ratio of the flow rates of two streams. So as I already mentioned, most of the cases the ratio in which the ratio of the particular inputs are very important. So in such cases the ratio controller takes the very vital role for such applications. Both the flow rates are measured, but only one can be controlled. So as we already understood that using a ratio, if only a single parameter or single value can be controlled or changed, so obviously the ratio can be maintained. One of the another one, if that is uncontrolled, that is not a point of concern. If one of the parameter or one of the value we can able to measure, able to control, so in such cases the ratio can be controlled. So that's why the both flow rates are measured, but only one can be controlled by the particular strategy. The stream whose flow rate is not under control is usually referred to the wild stream. So one of the stream which we have not able to control, that particular stream is known as the wild stream, and another one which we are able to control, that is called as a controllable stream. If we talk about the properties or the benefits using this particular ratio control, we can say that it's able to maintains the proportional flow rates. So basically the flow rates is very important for the case of the ratio control. So the proportional flow rates can be maintained using this ratio control. Improved product quality. So obviously if you have the ratio needs to be maintained and the ratio is maintained properly, then the output or the product quality can be enhanced. For most of the cases in the chemical plants, the ratio maintaining of two of the chemicals are very important. In such cases the improvement of the product quality can be maintained by the ratio control. Automatic adjustment. So basically the secondary based controller or the flow of the secondary stream is very important over here, and ensuring the desired ratio is maintained even the primary flow is fluctuates. So while stream may be fluctuating, but the controllable stream needs to be maintained in such a way that the adjustment can be done. Energy and resource optimization. So obviously the ratio control reduce the waste and improves the efficiency by ensuring that the resource like raw materials or the energy are not overused or unutilized. So it is another point of the discussion for the ratio control. Critical in multiple stream processes. So in essential process that involves the multiple input streams such as fuel to air ratio in combustion system, as already I have mentioned for the boiler, or chemical mixing process, it is very important to use the ratio control in a desired way. Robust again disturbances. So as I already mentioned, it is nothing but another control strategy which is very much influenced by the feed forward control. So ratio controllers compensate for disturbances in flow or pressure to maintain the accurate proportion in real time scenario. Ease of integration of modern automatic systems. So basically the PLC, DCS, these are the modern or the advanced control system can be used for the ratio control. So that is another point. Safety and process stability is the last point, which is nothing but the hazardous point we are talking about, the hazardous condition we are talking about. That is also important for the case of the ratio control. So we'll just try to visualize one of the scheme which is we have given as a scheme one. So here you are able to see two of the stream we have talking about. One is named as capital A, another name is capital B. One of the name which is noted as capital A, it is considered to be as a wild stream, whereas that means we are not controlling, we are not try to control this wild stream, otherwise we are try to only get the information to make the ratio of that particular value of the wild stream and the controllable stream. But one of the very important point is the wild stream is not at all controlled, it is only monitored. So that's why the FT, the flow transmitter, will measure the value of wild stream only, whereas for the controllable stream, which is denoted as capital B, here also we are making the same arrangement of the flow transmitter, and using this flow transmitter value of both the sides A and B, we are just dividing the value and we are getting the ratio. And using this ratio, we'll try to measure the desired ratio, try to find out the error, and the ratio controller will take the corrective action only in the controllable stream, not the wild stream. Because if the controllable stream value we are changing as per the change of the wild stream, the ratio can be maintained. So that's why it is it is a point of discussion in which the wild stream only the flow transmitter measure the value, not try to control the value. Whereas the controllable stream, using the flow transmitter, we are measuring the flow rate as well as we are trying to controlling it by the valve strategy or the control valves incorporation. So this is nothing but the PNI diagram of the scheme 1. Here you are able to see this is the flow transmitter for both the sides. So from both the sides we have a flow transmitter A for the wild stream, flow transmitter B for the controllable stream. Here we have a flow auxiliary, basically square root extractor is needed for the case of the DPT, differential pressure transmitter, and after that the ratio will be calculated at that particular point, and the ratio controller, which is nothing but obviously the flow indicating controller, because we are trying to concern about the flow. So the flow rate will be flow indicating controller will be control the flow rate, and as per the flow rate, the control valve, the flow control valve will actuate the valve and try to maintain the ratio as per the desired or the set point which is given at the initial. Scheme 2, here also and the same type of strategy, but nothing but the other one. So here also you are able to see the wild stream, and the B is nothing but the controllable stream. So both the cases the flow transmitter we have given. So try to find out the desired ratio, try to find out the error, and the ratio controller will try to acknowledge by the flow indicating controller and try to give the corresponding control action generated, and this control action will be affected by the final control element, which is nothing but the control valve. And this is nothing but the PNI diagram of such kind of scheme, or the scheme 2. Here you can see the wild stream is nothing but indicated as capital A, and the controllable stream will be indicated as capital B. So here you can see for both the cases FT1, which is the flow transmitter 1, which is measuring the value of the flow rate in the wild stream, whereas this is the controllable stream which is taken care by the flow transmitter 2, FT2, and here it is nothing but the segment given as a orifice. It is the orifice incorporation. Using the orifice incorporation, we are trying to measure the flow rate. This is the head type flow meter we are talking about. After that, using the flow fractional control, what we try to make, we try to make the fraction of the FT1 and FT2, try to find out the ratio over here, and using the ratio, the flow fraction controller will try to make the corresponding control action, and this control action will be given to the final control element to make the desired value of the ratio which we need to be maintained. So it is another type of approach. We can say the ratio flow transmitter FT1 sets for the controller FT2. So whatever the mentioned we have, or whatever the point we have mentioned, so that is another scheme, or the scheme 2, which we will try to discuss. If we talk about the application area, so application area, there is a huge application for the case of such kind of operation. For the case of the feed forward control, most of the cases in the industry, the feed forward control are being used with the incorporation of the feedback control, because without knowing the actual process, it is very unexpected to control using the feed forward one. So there is a lots of chance that the error will be generated at the time of your control strategy, or the offset will be there if you are try to find out the closed loop response. So it is a point of discussion for the case of the feed forward one. And benefit of the feed forward one, if you talk about, you can approximate, you can try to be anticipate before a disturbance it can be happen to your process. Whereas for the case of the ratio control, if we talk about, this is the fuel air ratio control in burners, most of the cases in boilers, there is a huge application of this ratio control. Control of the ratio of two reactants entering in a reactor as a desired ratio is a very important point of discussion using the ratio control. So most of the cases in the chemical plants, if you try to find out that the ratio control is very important for the reactants which are entering to the reaction chamber. So that is the point of discussion where the ratio control can take a vital role. Maintaining the ratio of two blended stream constant in order to maintain the composition of the blend at the desired value. So in such cases also, the particular applications can be find out where the ratio controller takes an important role. So from the entire discussion, we are able to see not only the feedback control is one of the option in our hand to control the any type of processes, whereas as far as the particular problem is concerned, if it concern about disturbance, so in such cases using the feedback control we can incorporate the feed forward one also, that can give a betterment in terms of anticipation that where the disturbance has been occurred. Whereas for the case of the ratio control, if we talk about the ratio control is another example in which if two of the stream will incorporate, two of the stream will be reacting, two of the reactants will try to react in a particular chamber or a process. So in such cases, this type of actions or this type of ratio control applications, there is a huge demand in the industry. So up to this, for this particular discussion, we'll meet in another discussion of the instrumentation engineering session in the next days. Thank you so much.